Preparing for a PLM Engineering at LTTS interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is PLM, and how does it support the product lifecycle? PLM is the discipline and technology used to manage product information and processes from concept to retirement. I would explain how it controls requirements, CAD files, parts, documents, BOMs, revisions, approvals, and change history. It creates a governed source of truth across engineering, manufacturing, service, and suppliers. In practice, PLM improves traceability, reduces duplicate work, and supports compliance. Its value comes from connecting technical data with business workflows, not merely storing files. While answering, define PLM, explain lifecycle stages from concept through retirement, connect people, processes, and product data, and mention collaboration, traceability, compliance, reuse, and integration with CAD, ERP, and manufacturing systems. Question 2. How would you compare Teamcenter, Windchill, and ENOVIA? Teamcenter, Windchill, and ENOVIA all manage product data, configurations, workflows, and collaboration, but their architectures, ecosystems, and customization models differ. I would compare CAD support, BOM management, change control, requirements, integrations, scalability, licensing, and existing customer skills. Teamcenter is common in Siemens-centered environments, Windchill aligns strongly with PTC products, and ENOVIA fits Dassault ecosystems. I would choose based on business processes and integration needs rather than brand preference. Make sure to cover each platform's role as an enterprise PLM system, core data and workflow capabilities, CAD integration, customization approaches, deployment considerations, and how requirements would guide a platform choice. Question 3. Explain the difference between a document, a CAD object, and a part in PLM. A document is usually information such as a specification, report, or procedure. A CAD object represents geometric or design data, often with native files, attributes, and relationships to assemblies. A part is a controlled product item used in the engineering or manufacturing structure, with an identifier, revision, lifecycle, and BOM relationships. A CAD object may describe a part, but they are not always identical. Separating them supports reuse, traceability, and manufacturing control. In your answer, distinguish informational files from managed engineering objects, explain metadata, ownership, versions, relationships, lifecycle states, and why parts represent product structure rather than simply attached documents. Question 4. How would you design an engineering change management workflow in a PLM system? I would separate the process into change request, analysis, change order, implementation, and verification. The request captures the problem and business justification. Analysts identify affected parts, documents, assemblies, requirements, suppliers, and downstream systems. Authorized reviewers approve the change order, after which controlled revisions are created and released through workflow. I would enforce role-based permissions, electronic signatures, effective dates, notifications, and a complete audit trail. The workflow should remain configurable and measurable. Be sure to mention change requests, impact analysis, change orders, affected objects, review roles, approvals, implementation, validation, effective dates, audit trails, and controls preventing unauthorized modifications. Question 5. What is a BOM, and how do you manage BOM changes in PLM? A bill of materials is a structured list of components required to define a product. In PLM, I manage parent-child relationships, quantities, units, find numbers, substitutes, revisions, and effectivity. Changes should occur through controlled workflows rather than direct edits, with impact analysis and approval. I distinguish the engineering BOM from manufacturing or service views, then synchronize approved data with ERP or MES. This preserves traceability while supporting different organizational needs. Focus on engineering BOM structure, quantities, substitutes, effectivity, revisions, units, configurable options, manufacturing transformations, and synchronization with ERP or MES without losing product traceability. Question 6. What is the difference between version, revision, iteration, and maturity state? An iteration usually records successive saves during work, while a revision represents a formally controlled variation of a product object. A maturity state describes its lifecycle status, such as in work, under review, released, or obsolete. Terminology varies by PLM platform, so I verify the configured model rather than assuming universal meanings. My key principle is that released data cannot be silently overridden. Changes require authorized revisioning, traceability, and appropriate effectivity. Cover how platforms may use these terms differently, distinguish working iterations from formal revisions, explain lifecycle or maturity states, and emphasize organization-specific configuration and controlled release practices. Question 7. How do you integrate a PLM system with ERP or MES? I first define system ownership. PLM typically owns engineering definitions, while ERP owns planning, costing, and execution data. Then I map parts, revisions, BOMs, documents, units, and lifecycle states between systems. I prefer supported APIs or middleware with validation, idempotent messages, retries, dead letter handling, and reconciliation reports. Release events can trigger outbound integration, while ERP feedback updates status. Monitoring, correlation IDs, and clear failure ownership are essential for reliable synchronization. In your answer, discuss ownership boundaries, object mapping, APIs or middleware, event-driven versus batch exchange, BOM and item synchronization, error handling, retries, reconciliation, security, and monitoring. Question 8. How would you customize a PLM platform without creating long-term maintenance problems? I begin with configuration. Data models, roles, workflows, forms, naming rules, and access policies. If behavior still requires code, I use documented APIs, extension points, services, and modular packages rather than modifying vendor core files. I isolate custom logic, define interfaces, add automated regression tests, document dependencies, and validate upgrade compatibility. Before delivery, I review performance and security. A smaller, supported customization is usually more valuable than a perfectly tailored but fragile solution. Mention configuration before customization, supported extension points, modular design, upgrade compatibility, API usage, automated testing, documentation, performance, security, and minimizing changes to vendor-managed core code. Question 9. What PLM data model would you create for parts, documents, CAD files, and relationships? I would model separate, meaningful object types for parts, documents, CAD representations, requirements, and change objects. Each needs a stable identifier, revision strategy, lifecycle, ownership, security policy, and business attributes. Relationships should represent precise semantics, such as describes, references, derived from, or contained in, instead of relying on file names. I would also define classification for reuse and search. The model must support traceability, reporting, integrations, and future business changes without excessive duplication. Be sure to discuss object types, attributes, identifiers, revisions, lifecycle policies, ownership, relationships, classification, reuse, constraints, and how the model supports search, reporting, and future integrations. Question 10. How do you implement access control and security in a PLM system? I apply least privilege through roles, groups, organizational context, and lifecycle-aware rules. Engineers may edit work in progress objects, while released data requires controlled change permissions. I separate author, reviewer, and approver responsibilities where needed, especially for regulated products. Supplier access should be limited to explicitly shared objects and attributes. Single sign-on, strong authentication, encryption, audit logs, and periodic access reviews complete the design. Security must protect collaboration without making normal engineering work impractical. Cover authentication, roles, groups, project or organization context, object-level permissions, lifecycle-based access, least privilege, segregation of duties, supplier access, audit logging, and periodic access reviews. Question 11. How would you migrate legacy product data into a new PLM system? I would begin by profiling legacy data, identifying duplicates, obsolete records, missing attributes, and inconsistent identifiers. Next, I define mapping rules for parts, documents, revisions, BOMs, users, and lifecycle states, followed by cleansing and transformation. I would load a representative pilot, validate counts and relationships, reconcile source and target results, and obtain user acceptance. Incremental migration, backup, rollback planning, and post-cutover monitoring reduce risk. Data governance must continue after migration. Focus on discovery, data profiling, cleansing, mapping, deduplication, identifier strategy, relationship preservation, incremental loads, validation, reconciliation, rollback, user acceptance, and post-migration governance. Question 12. A PLM workflow is taking too long. How would you troubleshoot it? I would first identify whether the delay affects one workflow, one object type, or the whole platform. I would review workflow and integration logs, database execution plans, queue or job status, server CPU and memory, notification volume, and permission evaluations. Large attachments, inefficient queries, synchronous external calls, and overloaded queues are common causes. I would reproduce the issue in a controlled environment, measure each change, and avoid disabling controls merely to improve response time. Mention reproducing the issue, workflow logs, database queries, server metrics, integrations, notifications, permissions, large datasets, queue processing, bottleneck isolation, baseline comparison, and safe performance improvements. Question 13. How do you handle CAD integration and check-in, check-out conflicts? CAD integration should map files and assemblies to managed PLM objects while preserving dependencies, attributes, and product structure. I use controlled checkout or workspace mechanisms so ownership is visible and concurrent edits are handled deliberately. Before check-in, validation should detect missing references, naming violations, and outdated dependencies. Conflicts are resolved by comparing revisions and coordinating with the owner, never by overriding released data. Clear user guidance and automated validation prevent most integration errors. In your answer, explain CAD to PLM mapping, ownership, workspace or cache behavior, dependencies, locking, check-in validation, concurrent engineering, conflict resolution, and protecting released design data. Question 14. What is configuration management, and how is it applied in PLM? Configuration management ensures that the product definition is uniquely identified, controlled, and traceable throughout its life. I define configuration items, manage revisions and baselines, record status changes, and perform configuration audits. For complex products, effectivity by date, serial number, or lot captures which configuration applies where. PLM can maintain as designed, as planned, and as built views. This prevents teams from designing, manufacturing, or servicing against inconsistent product information. Cover identification, baselines, configuration items, version control, status accounting, audits, effectivity, variants, as designed and as built views, and maintaining consistency across product artifacts. Question 15. How would you troubleshoot a failed PLM-to-ERP integration transaction? I would trace the transaction using its correlation ID across PLM, middleware, and ERP logs. I would inspect the payload, mapping rules, authentication status, endpoint response, and whether the failure is transient or data-related. Transient failures can retry safely if messages are idempotent. Invalid master data should be corrected and reprocessed deliberately. I would quarantine unrecoverable messages, notify owners, and reconcile source and target counts afterward. Every correction should remain auditable. Be sure to discuss transaction identifiers, source and target logs, payload validation, mapping errors, authentication, network failures, retries, ID impotency, dead letter queues, correction, and reconciliation procedures. Question 16. How do you approach requirements traceability in a PLM implementation? I create a hierarchy from stakeholder needs to system, subsystem, and detailed requirements, with ownership, priority, rationale, and verification criteria. Each requirement links to designs, parts, tests, risks, and changes. Baselines preserve approved snapshots, while impact analysis identifies downstream artifacts when a requirement changes. Traceability reports should show coverage, verification status, and unresolved links. This approach supports engineering decisions and provides defensible compliance evidence during audits. Mention requirement hierarchies, attributes, baselines, relationships to designs and tests, change impact, verification status, ownership, compliance evidence, and reporting across the product lifecycle. Question 17. What automation would you build for a PLM engineering team? I would automate repetitive, rule-based work first. Identifier generation, mandatory attribute validation, duplicate checks, BOM consistency checks, release package preparation, and stakeholder notifications. For imports, I would provide templates with validation and clear error reports rather than silently accepting bad data. Automation should use supported APIs, preserve audit history, and route exceptions to users. I measure success through reduced cycle time, fewer data defects, and improved first-pass approval rates. Focus on repetitive high-value activities such as numbering, metadata validation, BOM checks, release preparation, notifications, imports, and reports, while covering approvals, exception handling, auditability, and measurable outcomes. Question 18. How would you gather requirements for an LTTS PLM client implementation? I would map stakeholders across engineering, manufacturing, quality, service, IT, suppliers, and management, then document current processes and pain points. Workshops and representative use cases reveal approval paths, data ownership, integrations, and compliance needs. I would perform a fit gap analysis against standard PLM capabilities, prioritize requirements by value and risk, and prototype critical workflows. Each requirement needs measurable acceptance criteria. This consultative approach is important in LTTS engineering service projects. Mention stakeholder mapping, current state discovery, process workshops, pain points, regulatory needs, use cases, fit gap analysis, prioritization, prototypes, acceptance criteria, and balancing standardization with client-specific needs. Question 19. How do you ensure data quality in a PLM system? I treat data quality as a process, not a one-time cleanup. I establish naming and numbering standards, controlled values, mandatory attributes, duplicate checks, and validation at creation or release. Ownership is assigned for critical domains such as parts and classifications. Dashboards track missing metadata, invalid relationships, duplicate records, and workflow exceptions. Periodic audits and cleansing address historical problems, while training and governance prevent recurrence. Quality metrics should connect directly to business outcomes. In your answer, cover naming conventions, mandatory attributes, validation rules, duplicate prevention, controlled vocabularies, ownership, dashboards, cleansing, governance, audits, and continuous quality measurement. Question 20. Describe a challenging PLM project and how you would explain your contribution. I would use a specific example involving a workflow, integration, migration, or CAD issue. I would explain the client problem, my responsibility, the analysis I performed, the solution, and the measurable result using a concise star structure. For example, I might describe reducing release failures by adding validation and clearer error handling. I would credit the team, discuss testing and stakeholder communication, and finish with what I would improve on the next implementation. Be sure to structure the response with situation, task, action, and result. Quantify impact, Explain technical decisions, collaboration, testing, risk management, and lessons learned relevant to LTTS client delivery. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.